So as I'm developing these surviving statistics videos, I'm talking about normal distribution and z-scores in the last lesson. And I wanted to think of a popular, easy to understand example, and it happens to be NBA playoff season. And so I'm going to use an example of LeBron James. So what do you think the odds are of LeBron James having a 50-point game at any particular game? Well, let's go ahead and compute that and figure that out. So we need to start with some basic statistics. And so I did a little internet searching, and as of today, I found out that LeBron James has played 1,492 games. He has scored a total of 40,474 points in his NBA career, which equates to an average points per game of 27.13. I also found a standard deviation online of 7.91. Now, because this is every game he's ever played in the NBA, we're going to be able to consider this a population, and that will enable us to use z-scores. And in my online research of LeBron James, I did see that his points scored per game does seem to fit a normal distribution. So we'll assume it's normal in this case. And again, as I mentioned, it's every game that he's played, so we'll consider it a population, which will enable us to use z-scores in this simple example of how z-scores and normal probability distributions work. Again, when our data is normally distributed, we will use a z-score to determine the area under the curve or the probability of a specific score happening. In this case, we're looking for a 50-plus point game, and so we can compute the z-score with the formula that we've used in the past, which is the value that we're looking for, which is 50, minus the mu, 27.13, divided by the standard deviation of 7.91. And that gives us a z-score of 2.89, which is a very high z-score. With a z-score of 2.89, you can see that there is very little area under the curve that will fit that z-score and beyond. Nevertheless, though, there will be some values there, and so we're going to figure out how much of the curve lies between 2.89 and beyond. So after we have computed the z-score, we can then use the standard normal distribution table to find the area from the mean to that particular z-score. So looking at the table, we go at the far left column, we find 2.8, and we go all the way to the right to find 2.89. We then find an area from the mean to that z-score of 2.89 of 4.981. Now that isn't the probability we're looking for. That probability has to be subtracted from 0.5. Remember, the 0.5, each half of the curve is below the mean and half of the curve is above the mean, and we're just looking for a tiny little area with the z-score of 2.89 and beyond. So 0.5 minus 0.4981 equates to 0.0019. So the probability of LeBron James scoring 50 or more points per game is, according to our calculations, 0.0019. So yes, indeed, there is a chance that LeBron James will score 50 or more points in any one given NBA game. Not a large chance, but there is indeed a chance. All right, and now for the disclaimers. This was meant just to be a simple example to reinforce how normal distributions work and computing the area under the curve using z-scores. In his career, LeBron James has actually had 14 games in which he has scored 50 points or more, and that computes to 1% of his total games. That is considerably higher than the 0.19% that we computed using the z-score. And again, this was just a simple example of how to use z-scores. If we're going to bet money on how many points LeBron was going to score, we would need to take into account many other factors like the team that he was playing, how well he felt, many other factors, and we'll cover how to do that in some later chapters in Surviving Statistics. And remember, all of these lessons are based on my textbook, Surviving Statistics, which is available on Amazon. And do remember to check out my website for downloadable files, calculators, and other resources.